Hi, everybody. I want to talk about it, projectbuilder.net, smallest multiple problem number 5. 2520 is the smallest number that can be divided by each of the numbers from 1 to 10. So if you take 2520 and you can divide it by 1 and 2 and 3 and 4 and 5 and 6 and up till 10 with no remainder. So if you do the mod, there's going to be no remainder. So the problem is that that's not such a large number. So if you do mod of a long, that's slightly bigger. But if you do want to do anything bigger than a long, then mod doesn't exist. So in Java, you need to use something like big integer, and you can do the mod of that. So, because there's a special function that doesn't, you don't need to create it. What's the smallest positive number that is evenly divisible? That just means there's no remainder by all the numbers from 1 to 20. So in theory, what we could do is we could just multiply all the numbers from 1 to 20, like factorial of 1 to 20. We can try and take out things like we know that we can take out an 8 because if we have 16, we can take out a 4 and a 2 and a 3 because we have a 9 and a 5 because we have a 10 and another 5, etc., and a 7 because we have a 14. So if you just look at all the numbers from 1 to 20 and you get all the factors of them, so I just listed all the factors of them, what we want to do is find the lowest common multiple of each of these. So one way to do it, which we did it before, was to do a double loop, just counting from, let's say, 100 up until factorial of it, which is just the biggest one that's possible, up until factorial of it. And then you just check to see if it's divisible by every number below it. So you just pick it, you start with one, and you get the minimum number that is. So you get the smallest number that is, and that should be correct, right? So that's one idea. Now, the other idea is that you just look through this and you find the lowest common multiple. So the minimum you need to create all of these is 2 to the 4. Okay. The minimum you need to create all these is 3 squared. You need at least one 5 because there's only one 5 in all these, a 7, 11, 13, 17, and 19. And this is the number you get if you multiply those. So how would we create something to do this? That's the question. How would you create something to get all the factors and get the minimum? So here's my idea. What I'm going to do is I'm going to create an array list, and an array list is needs to be of some wrapper class type. So you say array list equals, let's just call it X, and we're going to say new array list and we're going to call it an integer, and we're going to make an empty array list. Okay, that's going to be our first step in Java. So because I don't know how many I'm going to need, so I'm going to have it. So that's going to be my list. Now what I do is I say I take 2 and I see, is 2 in here? No, so I put it in. Then I take 3. Is 3 in here? No, so I put it in. I take 2, 2. Now there is already 1, 2 in here, so I only really need a second 2. So what I have to do is find that is figure out how to do that. How do I say that this list already has a 2 and a 3, and this list has a 2 and a 2? So what I really need to get to is 2, 2, 3, and in this. So what I'm going to do is I'm going to do a double loop, but I'm going to say for each of these values, I want you to check if it's in here. If start with 2. If it's in here, then get rid of it. Okay, it's in there, so get rid of it. Okay, now check for 3. Is it in here? No, so fine. So now what I'm going to do is I'm going to take my original list and I'm going to add to it whatever is missing. So I add the 2. Okay, so that's how I add the 4. Now I do the same thing for 5. I have this list, and this is my new list. Let's just put it here. And I have a 5, because that's the next number, and that's the factors of it. So is a 2, is it a 2? No. Is it a 3? No. Is it a 2? No. So I'm done. Okay, now I have a 6. So I check. Okay, does this have a 2? Yes. If it has it, then you exit out. Okay. Does it have then I go to the next. Does it have a 3? Yes, has a 3, exit out. Okay, I'm done. 7, it doesn't have it, so I'm going to end up adding it. 8, 8 is 2, 2, 2. So what am I going to do? I'm going to say, does it have a 2? It has a 2, so I knock it out. Then I go, it has a 3? No. It has a 2? Yes. It has another 2, so I knock that out. Has a 5? No. 7? No. Okay, so now I add the 2. Okay, and this is how I'm getting the lowest common multiple of this, by doing a double loop that's just adding it whenever something is missing from what I took out. That's my idea about how to do that. So we need to use an array list, and we're going to have an array list, and we're going to check each factor. So we have to figure out also how to get factors of everything. So how would I get the factors of 8? So what I do is I check every number below it and see if it goes into it, and then I just keep adding that into it. So that's what I'm going to do. So I have, let's look at the factors first. So it's going to return an array list of integer, and this is generic, and you have to give it the wrapper class over here. Like you'd have to say double with uppercase or integer with uppercase, etc., in order to do that. And next, I'm going to call the name of the function and say get factors with the int. So now I'm creating the factors. So I get an array list and I'm making an empty list. So if I want to add something to it, I have to do the dot add. So I'm going to start with a counter of 2. While num is not equal to 1, let's just say we have 8 for now. If num mod counter is 0, so I start with 2. So I take 8 and I do it mod 2, that is 0. So I do x dot add counter. I add counter to x to the array list, and array list can change size. You just have to add to it. And then I do num divided by counter. So I take 8 divided by, and now I have 4 left. Okay, so then I do it again. If num mod counter, yes, there's a 2, so I add another 2. And then I now have 4 divided by 2 is 2, and then I do it again. Okay, and now I have 2, and then I do it, and then I have 1. And so while it's not 1, which it is now, so I stop. So then I return x. So the array list, because that's what I'm returning, is 2, 2, 2. Now, let's say that I had 84. Okay, so I start with 2, and I see, is 2 a factor? Yes, so I add 2, so now it becomes 42. And then I do it again, and it becomes 21. And then I do it again, and no, so I increase counter, so now I'm going to check for 3. So num mod 3, 21 mod 3, yes, so I add the 3 to this list, and then I get a 7. And then I don't see another 3, and I don't see a 4 or 5, and I don't see a 4 or 5, um, 6, etc., right? But I see a 7, and then it becomes 1, and then I return it. So that's how I get the factors. So now, for problem 5, here's what I'm going to do. I'm going to create an array list, call it LCM, lowest common multiple. It's going to be the lowest common multiple list. And then I'm going to create something that goes up until num. So this is a generalization. It's not just till 20. You could put in any number you want, and it's going to be much faster. So for int I equals 2 up until num, so from 2 to 20. Create an array list of factors now for 2, then 3, then 4, then 5 up until 20. And in order to check this, I need to walk through an iterator. What an iterator does is it can look through an array list. So I say iterator integer LCM iter equals LCM.iter. So the LCM iters are going to be the tool that allows me to walk through a list. Now, you cannot do this other ways. Even though an array list, you could usually say something like, I want to do a for each loop or something like that. What I'm going to use, you need to do it this way with an iterator because I'm going to remove stuff from it. Okay, so while LCM.iter has next, so while there is another number in there, I want you to create and iterate. I want you to get the value and put it into here. And remember, it's of type integer, uppercase. So LCM.iter next, that means the value that it is for the first number, the second number, the third number that's in my list of factors, if it has a factor at all, right? If it's assuming it has a factor, then assign it to LCM.iter, LCM int as integer. Now create an iterator for my second list of factors. So I say iterator integer, factors iter, factors iterator. So it's called factors iter. So now I have an iterator that's going to start from the beginning for my factors array. So while factors iter dot has next, so as long as it has something in there like 222 or whatever, 3722 or something like that. So then I'm going to say get the value of that one of the values for each of those. So factors dot next, which is going to be the value. For instance, if it was 22237, it'd be a 2, and it's an integer also. So this matches. This is integer. This is integer. So if LCM int is the same. So if you found from your original list, the LCM, the lowest common multiple list, you found that you contain a factor, then factors iter dot remove. Then remove the factor from my factors because you already have that, so you don't need it. And if you have it, then break. You don't need to check the next numbers, then go back and go to the next one in my LCM list and then see if it's contained in here. If it is, then you remove it, right? And then you go back and you can remove it. Now, the reason factors iter can do dot remove, it has a dot remove, right? So therefore, I'm going to keep creating these and starting it again over here. Now, once you removed everybody that needs to be removed, then you add any remainders to your list because that's whatever you didn't have. That's whatever you didn't have. Now I'm just going to sort it. Collections that sort LCM collections is how we can sort because this is an array list. And then I'm going to print it LCM dot for each. This is a for each print, which is just a little bit smoother to write. System that out that print line. This is using what's called a functional interface because print line just has one job, and so you don't even need to say X is going to be printing. You just need to say it like this. So we're printing our list. So this is a pretty fast problem. So you can see I have this, and if I run it, you could see, in fact, that it gets exactly what I should have. So this is a lot faster. This took all of 0 seconds. Now, this other way I did it that I mentioned originally, where I'm using a big integer, and I had made a video before about how to do this, but it's using a double loop. It has a for loop with a big integer and a second for loop you're checking. This took 14 seconds to run. So even though 14 seconds might not seem quite a lot to you, it grows exponentially and it's going to take a very long time. And here we're using lots of objects and we're recreating them and testing tons and tons and tons of numbers that are going to grow very quickly for each, while the way that I did it the second time is going to be the what I called problem 5 better because it's able to set this up. So this is a effective way of doing finding the value that we need over here. So this is Project Euler problem number 5, and we're discussing an array list and how to set it up. Okay, thank you so much, and I will see you soon.